Now, as much as we love epic space battles with blasters cutting through the black void and causing cheerful booms, that's not exactly what happens when something explodes in the big black. Space is basically vacuum, meaning it has no oxygen, and oxygen is an essential part of any process of burning we have here on Earth. You might argue that stars can burn and explode into supernova, but that's not exactly true either. Stars don't rely on oxygen, so they're not burning. There are constant thermonuclear reactions going on inside them. So a spaceship can only explode like that if it has a nuclear power plant installed in it. If it doesn't, then the only special effect you get is a brief flash that disappears in the blink of an eye. Liquid oxygen, which is often on board spaceships, is very quick to burn out in the vacuum of outer space. As for the boom, oxygen plays a crucial role here too. Sound only travels thanks to molecules of air bumping into each other. Since there's no air in space, the whole scene would be pretty much absolutely silent. And that's not a bad thing either. Just imagine how deafening would the sun be if the sound could travel in space. Despite what many sci-fi directors want us to believe, there's no dark side to the moon. Our satellite is tidally locked with Earth, meaning it's always turned to us with one side, while the other always looks away. The sun is much farther from us than the moon, and we're both turning round and round, warming and lighting this side and that in turn. It means that once in every short while, the moon is lit by the sun from either side. It's just that we can't see it from where we are. While things appear weightless in outer space, there's actual gravity all over the place. It becomes weaker the further you get from a heavy object, like our planet, but it's still there. In fact, there's not a single place in the universe that isn't affected by gravity of this or that cosmic object. Everything that has mass has gravity as well. Yes, even you and me. But space objects are so massive that they tug smaller things towards them. That's why the planets of the solar system orbit around the Sun, and our whole Milky Way galaxy orbits around its own center. Scientists believe there's a supermassive black hole there, about 4 million times heavier than the Sun, which keeps all the stars and systems from flying apart. Our movie hero leaves the orbit of Mars on their trusty spaceship and heads on towards Jupiter. Their face is grim and determined, even though they know what threat awaits them ahead – the asteroid belt. They pitch and yaw, dodging the asteroid flying at enormous speeds toward the spacecraft, but one of them still hits it. No, just a scratch, thankfully. Finally, our hero leaves the danger zone and wipes the sweat from the brow with a shaking hand. Sounds familiar, but couldn't be further from the truth. Asteroids in the belt between Mars and Jupiter are so few and far between that if you ever travel through it, you might not even encounter one the whole way. There are about 1.5 million sizable space rocks flying there, give or take 500,000. But let's not forget, space is a vast place. The distance between two asteroids of any significant size would be millions of miles. So a space chase with two ships weaving between floating rocks would be quite boring in there. Space is often depicted as a black, cold, and desolate place, especially when a movie astronaut leaves the safety of their spaceship. Everything about this description is okay, except for the cold part. It's only true if you find yourself in some really far corner of our galaxy that has no nearby stars. But if you're, for example, in the Earth's orbit and directly facing the Sun, the temperature in the cosmic vacuum could reach a scorching 250 degrees. That's why spacesuits are white. This color reflects light better than any other. Still, the temperature at your back, which isn't exposed to the sun's rays, can be really freezing indeed. Heat doesn't spread equally through space, so if you're not turned towards a heat source, you get very, very cold. Speaking about the sun, it somehow always appears yellow in movies. The fact is, the color we see from Earth is an optical illusion created by our planet's atmosphere, just as the blue sky during the day. The light from the sun spreads in the atmosphere and gets distorted, making colorful spectacles at dawn and dusk. In the vacuum of space, there's nothing to reflect the light, so the sun appears as it really is, white. That ball of glowing gas is that hot. There's a bright flash in the sky, followed by a tail of smoke and a red-hot space rock crashes into the ground, leaving a huge charred crater after impact. Well, although the smoky tail and the crater are partly true, meteorites don't really have a chance to become that hot while falling. Meteorite is an asteroid that somehow entered the Earth's atmosphere and survived the friction enough to fall on the surface. This happens pretty often, we just don't usually see those rocks because they're normally quite small and fall into uninhabited areas. But even if one falls within a city, the crater would appear because of the sheer speed of the meteorite, not its heat. They do get much hotter because of friction, yet not so much as to burn everything on the ground on impact. As much as we want to believe in instant communication between spaceships and planets, it's not possible, at least not yet. Modern communication systems rely on radio signals that have a pretty slow speed compared to the vast expanses of space. It would take years for such a signal to travel even 1 light year, let alone hundreds and thousands. If you want to send a message to a galaxy far, far away, be prepared to wait a couple of millennia and then a couple more to receive a reply. On that note, space is not as crowded and full of events as is often shown on the silver screen. It's mostly a rather lonely place where planets, stars, and other objects are separated by billions of miles of nothingness. Even if you have a spaceship that can travel at the speed of light, most of the time you'll only see black void full of stars and planets far away. The distances are enormous out there, even between the closest objects. For a better understanding, the Moon, which you can see so well on a clear night, is about 239,000 miles away. It's like traveling around the Earth almost 10 times in a row. Warp drives that can distort space-time and get you to a distant corner of an alien galaxy in the blink of an eye, that's a staple of any space opera. Spaceships capable of such a feat are always shown as instantly accelerating from zero to faster than light. According to the law of physics, people on board should, well, at least be pushed into their seats hard. More strictly speaking, no one would be able to survive such an acceleration because it's too many G's on a fragile human body. Until we find a way to reduce the effects of overload, we can't even start thinking of space warps. Water isn't the rarest and most precious resource in the universe. In fact, there's a humongous space cloud several million light-years away from us that consists entirely of water. Its reserves would be enough to fill all our oceans 140 trillion times over. And many planets, some even in our solar system, seem to have liquid water on them. The most precious resource in space is life, and that requires a lot more stuff to appear than just liquid water. Astronauts are often shown working out on the ISS and sci-fi space stations, and that much is true, they do need physical activity. But the reason isn't that they need strong bodies to work in space. The gravity out there is much weaker, and astronauts don't use their muscles as much as on Earth. So when they come back to the surface, gravity hits them as a sledgehammer, and their bodies feel squishy. To alleviate those effects, they train every day. Although they say we can see millions of stars on a clear starry night, that number is much more modest, about 3,000. All the rest are other objects that are also luminous and mistaken for stars, planets, distant galaxies, and even artificial satellites. They're simply being illuminated by real stars, just like the Moon, and become seen. But because they're that far away, we can't tell if they're stars or not. Still, you gotta admit, it's all still pretty cool.
That our sun wasn't always lonely. It could have had a companion star called Nemesis. They've noticed that mass extinctions on Earth occur every 27 million years. It's like a cycle. So, they turned to the stars to find out what the reason might be. And then, they assumed that it was a star that left our sun a long time ago, but it still affects us. Nemesis could be located about 1.5 light-years from us. It may not sound like a lot, but it's actually almost 9 trillion miles. That's gonna be a fun car trip, 50 million years long. Anyway, every time Nemesis passes its orbit, it can affect the Oort cloud. The Oort cloud is an area surrounding our solar system in which comets are formed. Its existence hasn't yet been proven, but scientists are pretty sure about it. So, comets form inside this cloud and then relocate to our solar system. Even being very far away, the second star in the system can have a great influence on it. But what about systems with 4 or even more stars? Is it even possible? Actually, yeah. But the more celestial bodies you add to the system, the more difficult it becomes. The orbits grow unstable. It's gonna be as chaotic as can be. In stellar mechanics, it's called the three-body problem. It says that it's very difficult to predict the orbits of bodies in such systems. In most cases, they turn out to be very random and unique. Isaac Newton was the first to have noticed it. He tried to apply his gravitational discoveries to the Earth, the Moon, and the Sun. He found himself with quite a struggle. It wasn't easy to understand how 3 stellar objects orbit so stably around each other. And that's just a planet and a satellite. How about including several stars? I wouldn't envy those who will have to calculate all this. Oh, right, it's me. Anyway, we know that triple star systems are ridiculously chaotic. But what about systems with more stars? They're very, very rare. In 2021, NASA discovered a star system of as many as 6 stars. That's just crazy. Of course, there are no planets in it, but who knows? Maybe one day we'll find such a system too. In such worlds, the gravity dance is very complex. It takes very specific conditions to hold everything together. It's like walking on a tightrope over an abyss. With all this in mind, let's try to imagine what would happen if the sun suddenly turned into several small stars. Oh, we're going to need a very detailed simulation. No, probably even a dozen simulations to make this thing work, because otherwise, we'd only have a few options. Option 1. We divide the sun into 5 to 10 tiny suns. Now we'll scatter these guys not far from each other. They'll destroy our system in a couple of hours. Yeah. All star systems, including ours, are in constant motion across the universe. So, they'll crash into each other almost immediately. This collision will lead to the creation of a supernova. Our system will turn into a beautiful, colorful nebula. For us, it will happen in just a couple of minutes. We won't even have time to feel anything. And all the planets in the X-solar system will immediately turn into sparkling space dust. But it's not the best option for us, right? Let's see if it can go any other way. Option 2. Since they can't be located so close to each other, let's try to set them as far away as possible. And in this case, they'll just leave. Bye-bye. Their gravitational force is too weak to hold everything together. The little suns will simply leave the solar system, flying into space in random directions. After that, the rest of the planets will descend from their orbits, including poor little us, of course. We'll become a so-called rogue planet. At first, we won't even realize that the planet has gone out of orbit, and we won't have time to do anything before it gets incredibly cold. What a sad and poetic end. In general, none of these outcomes sounds very fun. Oh, alright, we still have the last option. Our main problem is that we make each of these little stars the same mass. But just take a look at all these multi-star systems that we've already discovered. You'll see that none of them look like a bunch of glowing balls together. Instead, there are a couple of large stars there, and the rest, the small ones, are orbiting around them. So how about 2 large stars and 2 small ones? What will the Earth look like then? Well, its orbit will become terribly unstable. We'll shake back and forth. Wouldn't recommend it, honestly. We know what this can lead to, because, and that's just crazy, this has already happened to us once. Yes, about 70,000 years ago, a lone star visited our solar system. It was a red dwarf called Scholz. A red dwarf is a very small and cold star, if you count 14,000 degrees Fahrenheit as cold, of course. But it's considered the weakest and coldest type of star, so it probably didn't look that big and bright in the sky. At that time, our ancestors, Homo sapiens, were already there living their lives. And can you imagine? They saw another star in the sky approaching the sun. I wonder what that looked like. And then, shoals bypassed the sun and flew somewhere further to surf space. You weren't expecting some kind of disaster, were you? If it had happened, you wouldn't have had a chance to watch this video right now. But from this story, we can see what happens to the Earth during such stellar events. At that time, a huge amount of volcanic activity unfolded on our planet. We also got some meteor showers that almost wiped us out. Our ancestors sure had it rough. Something similar will happen on our hypothetical planet with 4 suns, but on a much greater scale. Constant volcanic activity, earthquakes, and tsunamis. Brr. In addition, the length of a day will change, as well as the length of all seasons, and a year as a whole. They won't be stable anymore due to the regular changes in gravitation. In other words, you'll never know when to expect an annual winter or hot summer. And when we are precisely in the middle between 2 stars, there won't be any nights at all. They'll illuminate both parts of our planet, and we'll have to sleep in bright sunlight. And if you think this is a bad thing, keep in mind that we'll also be attacked by much more ultraviolet rays and solar winds because of our 4 suns. Their color will also change. They'll become red dwarfs, looking distinctly orange-scarlet in the sky. We'll also get many more solar eclipses, except instead of the moon, the sun would be eclipsed by another sun. It would probably just get a little darker. To be honest, it's unlikely that anything would survive on Earth after all this. I mean, it is possible, but please run 100 simulations yourself if you want to make sure. But theoretically, we could survive in a simple binary star system. For example, in one that consists of 2 stars close to each other. Each of them would have to be 2 times smaller than our sun. That would be the perfect scenario. And it's quite possible in the future. NASA is currently working on a plan to relocate our descendants to Proxima Centauri b. That's a planet near the closest star system to our sun, Alpha Centauri. And who knows, maybe one day in the future, we'll really move there. Then we'll see what it's like to live with several suns. In July, when we're about 94 million miles from the sun, the world is about 36 degrees Fahrenheit warmer overall than in January, when we're 3 million miles closer. This is because there's more dry land in the northern half of the planet than the southern half, and land tends to heat up more than water. During the northern summer in July, more land is heated up than in January. So the planet gets a little warmer at this time, even though we're further from our source of heat. The closer the moon is to the horizon, the larger it looks. This phenomenon is called the moon illusion. One of the theories explaining it claims that the atmosphere plays the role of a magnifying glass, which makes the moon look bigger. In reality, if the atmosphere had a say in it, the moon would actually look smaller, not bigger. Most experts believe that the illusion is created by your own mind. It can increase the moon's size more than twice. When Earth's satellite is high up in the sky, you don't have any visual cues about how far away it is. But when it's near the horizon, you can see objects surrounding it in detail. It makes the moon look larger. But it's just one of the many theories explaining the phenomenon. By the way, you can trick yourself out of this illusion if you bend down and look the moon upside down through your legs. A day on Venus is longer than a year. It takes the planet 243 Earth days to rotate around itself, and only 225 Earth days to make a full circle around the sun. Around 5 million years ago, the supermassive black hole at the center of our galaxy launched a star from itself, and it's now traveling through the Milky Way 10 times faster than any other star out there. Saturn's rings are very thin compared to its size. If you had a scale model of the planet that was 3 feet wide, the rings would be 10,000 times thinner than a razor blade. Mercury is a few billion years old. In 2016, scientists discovered some abnormalities on the planet's surface showing that it's getting smaller. After more research, they found out that Mercury hasn't finished cooling down yet. The Earth and the Moon are gradually drifting apart, as slowly as your fingernails grow. This is the flip side of our satellite's gravitational force. The Moon creates tides in the Earth's oceans. They pull back at the Moon and make it speed up. This in turn moves the satellite to a higher orbit. In prehistoric times, the moon was way closer to our planet than it is now. Luckily, we aren't going to lose the moon. The farther away it moves, the weaker its gravitational pull becomes. It means that soon, our planet won't be pushing the moon away with such a force. Discovered in 2017, Kelt 9b is the hottest planet we know of. Next time you're complaining about the heat on a scorching summer day, just remember that temperatures on this planet can reach 7,800 degrees Fahrenheit. That's because it orbits really close to its star, which is called Kelt 9. This thing is way hotter and bigger than our sun. Experts believe that the giant star might someday evaporate the entire planet with its intense heat. Kind of a sizzling solar sauna, wouldn't you say? Everything on Earth, and everything people have managed to see in space with the help of telescopes and other instruments, is normal matter. It's made up of atoms and molecules, and adds up to less than 5% of the universe. Almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if several decades ago they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite, it was accelerating. It meant there had to be some enigmatic force that counteracted gravity. It got dubbed dark energy. Cold welding is a phenomenon in space when two pieces of the same metal join together without any trouble and heat. About 700 million years ago, a mysterious event that occurred may have turned Venus into the place it is now. Admittedly, astronomers can't see the surface of the planet directly because it's covered with dense layers of thick clouds. But space missions that have been sent to the hot planet found that Venus is peppered with fire-breathing volcanoes, massive mountains, countless craters, and gigantic lava plains. The temperatures on the planet are so incredibly high that they could melt lead. And the atmospheric pressure is so immense that it would instantly crush any living being reckless enough to set foot on it. If that's not enough, the atmosphere of the planet is filled with noxious clouds of sulfuric acid, which smells worse than rotten eggs. Carbon dioxide, the main component of Venus's atmosphere, along with the infamous sulfuric acid, create a powerful greenhouse effect. As a result, the lower atmosphere and the surface of the planet are some of the hottest places in the whole solar system. Neutron stars are the size of a small city, yet their mass is about 1.4 times that of the Sun. They're formed when massive stars die and their cores collapse in on themselves. The core continues to press in on itself until all the electrons are essentially crushed together, leaving only neutrons. This makes neutron stars one of the densest objects in the universe. In fact, a single teaspoon of neutron star material would weigh 1 billion tons. Of course, getting this sample and delivering it back to Earth might be a difficult task, since the gravity on a neutron star is 2 billion times stronger than the gravity on our planet. Because of the effect the moon has on Earth, our planet is gradually rotating slower and slower. And I mean very gradually, at around 17 milliseconds every 100 years. So, it will take 140 million years before the world can add a single extra hour to its day. But that also means that when the dinosaurs existed, there were only 23 hours in a day. There's very little activity going on inside the moon. Plus, there's almost no atmosphere around. That's why scientists can trace impact craters littering the satellite's surface back billions of years. While dating the craters, astronomers discovered that the moon, along with our planet, went through a late heavy bombardment about 4 billion years ago. This event is also known as the Lunar cataclysm. This interval lasted several 100 million years. During it, an unusually large number of asteroids collided with Earth, Mercury, Mars, and Venus. The newest scientific theory claims that Venus could have had a pleasant, stable climate for billions of years before something went wrong. Astronomers did thorough research and built a model of a virtualized Venus-like world. This model demonstrated that for most of its history, the hot planet had oceans with liquid water, adequate temperatures, and stable tectonic plates. In fact, the planet resembled Earth as it used to be at the beginning of its life. Scientists suppose that this period of Earth-like development could have lasted for more than 3 billion years. Saturn is a planet with winds that travel at more than 1,100 miles per hour at the equator. It's also the planet with the most prominent rings. The atmosphere of Saturn isn't really different from its surface, but the deeper you go, the higher the pressure becomes, and hydrogen becomes liquid. Further to the center of the planet, this liquefied gas turns into metallic hydrogen. Like Jupiter, Saturn might have a rocky core, with hydrogen and helium surrounding it. On the other hand, even if it is made up of rocky material, the core can still be liquid. Humans have been exploring space for over 60 years, and the effort has certainly paid off. All the planets in our solar system have now been explored, even the dwarf planets of Pluto and Ceres. Most of the exploration was done by NASA's Voyager program, which began in 1977. Voyager 1 and 2 collected information on the planets, their moons, and their unique systems of rings and magnetic fields. These twin spacecraft continue to send data back to Earth, and Voyager 1 is currently in interstellar space. The sky might appear pretty peaceful as you look at it from Earth, but the Milky Way is headed for a massive collision with the Andromeda Galaxy. 4 billion years from now, you can set your alarm. These galaxies will meet, and neither will survive. Stars will be scrambled, and constellations will be undone. Eventually, the two giants will merge and form an elliptical galaxy. But according to National Geographic, our Sun and Earth will survive. Any life forms on Earth will be treated to a splendid sight as the galaxies come together.